Good evening, everyone. My name is Michael Royster. I'm with Microsoft, and I'm a cloud solution architect. Everyone knows Phil, the same role as Phil. I've been in the Azure business a long time. I've just actually checked my email history folder to work out when I actually started. So it was 2010. So I've been nearly 11 years now. So been on this journey for a long time. And topic of the conversation, it's a topic that I've had with many customers around designing resilient applications and available solutions in Azure. It seems to be a topic that people are interested in. I originally did this talk, put it together actually for the Northern Azure user group up in Manchester, and got asked to come and do this Midlands one, which I'm really disappointed. I'm a Midlander by birth, so I sort of was looking forward to a trip down physically, but it was not to be. I'll have to come to another event instead. Anyway, moving on, which it is not moving on. Yeah, so building reliable systems in Azure is actually a shared responsibility. It's not actually, there's a resilient foundation that is built into the Azure platform. That's what Microsoft take on and build for you and manage. But I have a lot of people with a misconception originally who are new to Azure. They deploy in one region, and Microsoft will magically make the application host. If we have a problem in, say, EU West, that application is suddenly running in EU North. That's just not true. So often resetting that expectation. So, but there are a whole bunch of resilient features that are built on the foundations that you can use to build and deploy your applications in a resilient way, and I'll go through some of those. But then if you're then writing an application, building it yourself, there are a whole bunch of other techniques and feature and capabilities that you should use to improve the availability. So when you buy a shrink wrapped application, if you're more from the infrastructure world, you're sort of hoping that someone who's built an application actually architected it almost as cloud native to Azure, that they use some of these capabilities in the application as well. Not many of them are not new at all, but they sort of come to the fore when moving to the cloud. So really, the agenda is really just those layers of go through a bit of introduction, go through the resilient foundation just to level set on that, go through some resiliency features, some common ones. There are a lot of them. I'm not going to go through every single one, and then touch on some application techniques as well. So that's the agenda. I just put some definitions, mainly because I'll probably say these words just so you know. Like the first is like an outage, which sort of think of that temporary condition that something's gone wrong and it will be fixed and come back later. More the disaster is actually that's like it's a permanent failure of if that Microsoft lost a whole region, for example. It's think about it that we can't go back to that data, or all that data is lost. So you sort of have to also architect and think about those disasters. Recovery time objective, essentially how long it takes to get your applications up and running, and the recovery point objective of what is the amount of data loss that you're in, so usually measured in minutes or seconds, that you're willing to lose in the event of a disaster or even an outage. But we're talking about availability. What actually causes unavailability of an application in Azure? Over time, hardware has got much more reliable. Networking has improved. Generally the industry has evolved and improved. Today, and this is probably true for a long time now, that the biggest cause of any failure in any application or any system these days is actually change. And this is sort of amplified in Azure. If you think about Microsoft underneath the covers is changing that platform almost on a daily basis. So anyone who's building resilient applications has also got to factor in that things do change. That what you do, you don't build the days have gone really if you deploy an application and then the art of keeping it available was never to change it. You don't have that luxury anymore. Most businesses want more agility and they want constant change, and you're living with constant change, whether that's software updates, application updates. So touching on the foundation. So just as a statistic, I've just taken this one. These aren't published very often. They're usually a keynote at Build. So this is probably the one from the keynote at Build last year. So that's the most up-to-date number I've got I can use publicly. So a single instance VM, the average rolling 12-month average uptime for single instance VMs is actually 99.997%. The VMs themselves actually only have an availability SLA of 99.9, but actually they are operating at nearly just under 5 nines. So there must be some things in the platform, because a single instance hasn't got that much resiliency built in. There's no zones or availability sets to increase. So there is some foundations there that is providing resiliency to you. And I think as the Midlands Azure user group, you've had a virtual DC tour. Is that correct?
That's right, Michael. Yeah.
So I think you probably saw some of that inside. So just a reminder, these are huge data centers made up of multiple buildings, which we'll talk about zones later, but that you'll see that they're made up, and they're all state of the art. It just makes more sense for Microsoft for everything to always be the very latest. They become inefficient if they get too old, so they are constantly refreshed. So those are sort of the foundations that you're building upon. So that the foundations really come into three main pillars: the actual design of the services themselves, the global network, the data center infrastructure, and the storage, etc. How Microsoft then actually operate that service, and something called safe deployment model, which I will come and touch on. How maintenance and everything is done. There is also a lot of machine learning in the operation of the data centers that is actually detecting potential faults and perhaps detecting a virtual machine that's failing. Its disk is probably beginning to fail. That is predicted, and the machine is moved to another rack, all behind the scenes that you just don't see. So there's a set of operations that is going on, more and more machine learning and predictive maintenance in there. And then there is the observability of all of that. So those are the some resilient pillars that Microsoft is doing for you. So in many ways, people have been deploying in their older historic data centers. Just moving to the cloud and Azure, you're getting that really resilient modern foundation that's probably stronger than many of the data centers that people are moving from. And in the data center design, I'm not going to go into a lot of detail on these, but the obvious redundancies in there in a data center, multiple power feeds will often. On my last tour of Dublin quite a while ago now, that they actually pulled off the power grid of Ireland, completely independent, off the national grid, straight to the data centers twice as independents. There are on-site generators, battery arrays that keep your machines and your other services there running in the event of a failure of the power. They tend never to be used in Europe, but in the US, where it has a poorer power supply, those type of redundancies do kick in more often. I'll come on a bit more detail on availability zone. So you saw in that picture, you sort of see it here, that a region such as Europe West would be made up of multiple data centers. You can see those in the picture on the left there, and they have independent cooling and independent power. So that becomes resiliency. So when you're deploying an application, you can you can utilize that physical separation to say, if you've got a say, a database cluster, the pair of machines that make up that cluster. Each machine goes into a different machine hall to get that independent power, should you choose to deploy it in that. And then we try to share as open source really a lot of this data center design. So others build on that and improve it as well. So it's a constantly evolving design that I can't remember which generation we're even at now. It's 6 or 7 that these generation data centers are constantly evolving. And in the networking coming into those data centers, everything is redundant as something called a regional network gateways that are redundant, such that allows any data center within that region be able to talk to any other data center and also get out to the internet and those peering connections through express route as well. And just show that 1.6 petabytes per second of what some of those gateways are capable of processing. So you've got redundancy in the data center design and the networking. And then a lot of work has actually gone on ongoing maintenance for when machines do, Patch Tuesday, both the host and virtual machines get patched. Probably thinking about more the host, if you think about that. So the first, there has been lots and lots of changes to the underlying operating system, which is a derivation of Windows, to allow hot patching. So essentially allow you to patch an operating system without requiring a reboot of the operating system. And more or less, they've done that for nearly device drivers. Everything does now support hot patching. If it can't be hot patched, there is also something called memory preserving. So essentially just pauses your application or the machine that you're running. It just pauses. The update pauses the guest VM. Everything just stops in RAM. The host is updated under the covers, and then that pause is removed and it just continues. So actually the pause is done less than a TCP IP timeout. So that is normally non-impactful also on the running guest. So that's also providing you that resiliency platform. There's some self-service maintenance as well, where you can allocate where it does require a reboot. You can give you a window to take that reboot if it is forced. I think the only times they really look at some security fixes that have come in historically. Last one was a few years ago now, probably 2 or 3 years ago, since ones that forced a reboot. And then what's also going on for they're sort of the planned, the unplanned maintenance is that if Azure detects there's that predictive that some hardware is about to fail, it would actually do a live migration of that VM to a healthy node and continue and heal that and continue from there if that is possible. If not, it will heal the VM on a reboot and reboot on another node, and you just see a reboot. So all of that is going on sort of under the covers to give you availability. So whether that's a virtual machine or the virtual machine, essentially under any of these services, a lot of whether it's Azure SQL database, CosmosDB, they're all ultimately compute, providing that. These are the things that are going on underneath those services as well to keep the services up and running. So that's sort of the infrastructure that's in place, and then sort of to allow Microsoft to how we test this. So obviously changes, and we talk about that change, development and test, staging, that sort of as you'd expect. But then when they're doing a change, then the first thing they deploy it to is what's called a canary ring. So that's actually internal to Microsoft, but it could actually be hosting Office 365. It's still a production service. It's just we understand the workloads that are on that a lot more and fully understand them. So we could detect if anything was wrong with that change that we're trying to push through. the environments at the time. If that's all okay, that you probably leave it for a week for something new coming out. It will then move through various environments. So the first they'd probably pick is a small medium region, deploy it to that, leave some bake time to see if that change is okay. If that is okay in that region, it will then move to a heavy region, such as the US, one of the US ones, or EU West or EU North. It would run there for a while and bake in. It would then, once that's all okay, it will then move on to the secondary, the regional pair, and essentially then roll out to the rest of the world. So this safe deployment practice is really trying to restrict, reduce the impact of a software change that causes availability issues in someone utilizing the Azure platform. So that's sort of a little bit on what's in the platform, and then the various Azure services all come with a set of a collection of resilient features that you could then exploit building your applications. That I'll not go through. There is a long list, whether it's within applications, compute, storage, databases, network, etc., etc. That there's a whole bunch of features in those services that provide resilience and availability to you as a consumer. So if we look at the first one as the platform, the first is a regional pairs. So these form a data residency boundary, essentially the same geopolitical regions for that. So that gives you the disaster recovery over a large geographic region if you're deploying it into that. Within the region, you have an ability to, as we touched on earlier, to have availability zones. So as I talked about before, so in a database, which is the easy example to see, the active passive pair could be in zone 1 and 2, and an observer for the quorum could be using that third zone. So that is a platform capability. It's being rolled out for the last few years now, and almost all services now have support for availability zones. Some still do not. For example, Azure NetApp Files is one I did check on today that still does not have any zonal redundancy in that service, although it still offers a 99.99% availability. And then at the more historic one, at like a cluster level or rack, is availability sets to at a cluster level to make sure if you start using availability sets, your two machines would not go into the same rack. So when any maintenance or updates are rolled out, or one of the racks fails, you don't have a single point of failure on that rack. Your application or VM is running across the two nodes in that availability set. So that, I think, I suspect everyone knows that inside out already, but I thought I'd include it in case they are new to the platform. Now, everyone's probably yawning a little bit on availability zones and all of that. I all understand that, but when you start digging into this, it's not quite as simple as it first seems. So here is there is for SAP that is extremely latency sensitive between the application server and a HANA database. So it has very, very stringent sub-millisecond requirements for the latency. So here in EU North, just pick this one, running one of the test scripts here, we can see that actually the latency between any of the zones is roughly around 50, 60 microseconds, which is all okay. We never have to think about that. That's all okay. Western Europe here is, if you actually go and run in Western Europe exactly the same test, you'll actually see between zone 3 and zone 1 is still 60 microseconds, as we see there, and between 1 and 3 there. But actually, these are going between zone 2 and zone 1 is actually 660 microseconds, so just over half a millisecond. So the reason really for that is one of the zones in Amsterdam is geographically a long way from the other two zones, so the latency lights up like that. In most applications, that sub-millisecond is absolutely fine. No one ever notices that, and you probably never even worry about it. But if you're actually running SAP, this becomes quite a big deal because of how latency sensitive the application is. So there is, for certain applications, proximity placement groups where you can actually specify in your ARM template that the two VMs need to be actually in the same zone and next to each other to ensure that you get low latency between that and you're not bouncing across those zones. So just something to be aware of. Most of the regions behave like EU North, but they're EU West, and I think there's one in the US that behaves in that way. But I'm most familiar with Western Europe based on a previous SAP project. And I've picked resiliency within storage, and I think you can really apply. I talk about storage here, but this really applies to any of those storage services. They all essentially follow the same model, whether it's a database, a NoSQL store or whatever. That there tends to be local redundancy storage, which is really sat within a single data center, 3 copies of the data within that data center. Zonal, essentially the 3 copies are then put in each of the separate zones. And then what you're particularly interested in from a disaster recovery are those ones that are copy across the geo-redundants that copy across to regions as well. So keep your 3 copies in region 1 and manage all the replication of your storage to the other region. In many cases, usually in the case of storage and the case of SQL and some of those, usually that your only ability to access the storage in that second region is through a read-only request. You can't do updates across that, and I'll come on to some of the technologies that solve that problem, but that is usually your challenge for that, is that how you do writes across in 2 regions, trying to run an active app across 2 regions. And if you just look at any of this is Azure SQL database, I think many of the storage ones will have a set of similar features. Point in time restore, geo restore, the ability to restore a copy of the database into another region, active geo-replication, which was sort of touched on in that storage, to replicating the database and having a read-only copy in the other region, and then auto failover groups of managing or automating the failover of those in there. So if you're building these deployed applications, you have a whole set of features you sort of exploit to give you your resilience. And here, in the case of SQL, you've got a geo application, so you're basically copying the data to the other region, but this other copy is only read. Your application can't do read and write here, but this doesn't stop you as an application developer. So rather than that, you can actually use this to create very, very resilient applications. For example, if I gave you an example, this is a model from a well-known UK fashion e-commerce site that many people probably buying clothes from. Think of this as, say, the shopping basket that's copying across here. So you've got the primary database, so users come through, they're into EU West here. They write and touch their shopping basket, and there's a copy of the shopping basket going to the other region, but there's no write copy here. So what you could do in the event of a failure here is actually have another spare database that's writable that hasn't got the shopping basket in the moment, but what you do is just go and then basically create a new shopping basket in the writable copy, but you've got a read-only copy of the original basket contents, and you just copy across the contents and recreate the basket in that without thinking about failing over the database. So, analogy in the real world would be your carrier bag walking around Sainsbury's or any other retailer. Snaps, you're basically getting all the carrier bag, pick all your tins of beads, etc., and put them in another basket, and off you go without losing that sale and that basket that would be lost. So you can, as an application, use these features to give extremely high availability in your applications. Now, this is one of the CosmosDB, a NoSQL database, has come along, and it's being used in lots of. I do a lot of work in retail for many high availability e-commerce sites, and one of the key features of this is the ability to have multi-master, such that you can actually do reads and writes to any of the regions, and those writes get replicated back, and the conflict resolution all happens, and the consistency models manage all of this for you. So for that, what Cosmos opens up for application developers or people building on this database is the ability to actually run active in multiple regions and around the globe without really having really complex failover routines and all of that. You just run active and wherever the user's landing, possibly to their nearest Azure region, they work there, or if that region fails, it fails over to the other region, and you carry on with no loss of data, no loss of service. So, we talked about the data, we talked about a little bit of the compute on that. So, the main, the issue you sort of face is how do you get the traffic into the application in the first place? And there are really two public services for do that. Traffic Manager, which has been around a very long time. I suspect many people know quite a lot about that, and Azure Front Door, which is actually what Microsoft use for most of our internal services, and most of Azure is built upon Azure Front Door. And then some more, the regional ones for App Gateway and Load Balance, which I'm not really going to touch on. So Traffic Manager, I'm not going to spend time, I haven't got time to sort of explain, but it's simply a DNS based. So and there are a number of profiles that you could run on this. It could be a failover or route you to your local region, or have nested profiles locate you to your local region. If that fails, send you to somewhere else. But it's all just DNS based. So you come in, you're looking for Contoso, your www.contoso.com. That hits you to your Traffic Manager. That will resolve you to your region and send you to that region. If it then fails, you sort of relying on the DNS timeouts for the failover. So there is an amount of time you have to wait to get to a working region. Azure Front Door has a number of services on there, such as SSL offload and some others, but the main availability feature that we're sort of always looking for, or the benefits of it over Traffic Manager, is it uses a protocol, TCP Anycast, that allows you to do an immediate failover, such if region 1 fails, the routing can now go to region 2. So hopefully that's give you an idea of a whole set of features that you can use for that. A lot of people, if you're in the infrastructure world, some of those you're probably aware of and can use to get your availability. If we move on to developers now who are building applications, what can they do to make the applications even more resilient? They will be using the features and the foundation we've talked on. So there is a whole set of resiliency patterns that they can apply. Some challenges with state and all-up architectures. I suspect, in the interest of time, I won't get all the way up to all-up architectures, but I'll see how far I can go. So here is just a few examples. If you looked in the Azure architecture sections in the documentation, they talk about these. Of retry patterns, a bulkhead pattern, caching. As a we talk about caching, typically about improving performance. In reality, caching can also improve availability as well. Deployment stance, circuit breaker, and throttling. And I'm going to touch on a few of these, try to bring them to life with some examples as well. So I think we've probably, the one that is the most common in cloud, particularly because it's often connected over public networks or hosted networks, is that the network does have occasional blips, and to have a retry pattern of, if the first request fails, don't just throw an exception in your application and report back to the user error 456 and stop. It's building in retry to that application as well, to actually back off for a period of time, or immediately retry and then have a back off time and keep retry that. So that sort of gets you over those little blips of something gone wrong, which is just intermittent, as perhaps some TCP's failing over, gets you past those initial blocks and allows the application to continue. And it is quite surprising. So one of the most, if anyone wants to look on YouTube and look about highly resilient applications, my favorite are any from the Netflix team. They are very open. How Netflix uses lots of resilience. It's also a pattern I think we all can understand. I think we can all understand the application pretty well as well. And they're very open in the mistakes that they've made in the past and how they've learned. And they've actually said in the past on that retry, going to one service once, they literally, the whole Netflix service would stop for a user on one service being out. It just stopped. And that was in the early days, and they've evolved to some very, very sophisticated patterns, which I'd probably highlight some of these, that they do use all of these. If you ever want to look it up, they've actually open sourced a lot of these libraries with Hystrix. So that was retry. Now, one of the problems with retry is if you're in a financial world, what if I just go and retry my debit from my bank account, and actually we don't know if that request really worked or it didn't. So imagine we're doing a request of debit £50 from account 007123. If I retry that request, I'm going to debit £250 from that account, because it's got there's no way to know that it's already processed that transaction. So in building these applications, you can make sure the requests are actually idempotent, which is the mathematical term, to make sure something returns the same result no matter how many times it's executed. So you can actually change that transaction rather than just be debit account from £50 from that account. If you made the request debit £50 from the account at this exact timestamp, and depending on the application, how accurate that little timestamp is, the application built the implementation of that logic for that debit could actually check of, have I done this transaction with this timestamp before? If I have, I'm assuming I'd already processed this. So that, building that into the application developers can build those idempotent capability into their services, such as that retry pattern for blips in various networks and services can be executed without worrying about what it's going to do to the application. The other pattern that's really useful for keeping applications available, something called the bulkhead pattern, and this is taken exactly the same from a ship, of partitioning the hull into sections such that if one section is breached, it doesn't sink the whole ship. This pattern doesn't always work well in shipping either. With the Titanic is a great example of that. The bulkhead wasn't quite good enough. But you can apply that exact same pattern into software components. So what you really want is, if one component fails, you get a graceful degradation of your whole application, and it doesn't all stop in one as a whole service, so you don't lose everything. So, for example, you had used Netflix or any website, or any e-commerce site the same. So often there is personalization, that you get a set of films or a set of clothes or something that you're looking to buy, that are something the retailer knows about you and will present something that's very specific to you. If that service to do the personalization is down, you still want to offer out a generic set of films or a generic set of clothes. So you sort of want to have that bulkhead, that if one thing fails, you don't completely fail, you fall back to another. The other you can do is like in connection pools. So you imagine you come in, that personalization service is down. So you just keep trying until you've used up all the threads of your whole application, and your whole application then breaks. But if you put them into a pool here's a thread pool just for talking to the personalization service, I just use those threads, but it makes sure I'm leaving threads to do. If that then fails and times out, I can still go and use other threads. I don't go and every user coming in and consume all my threads. I can use that bulkhead to protect threads in the application. And cache aside, essentially caching data, which is normally done for performance, but imagine for availability. So you want to look up your films in Netflix. The service that's serving the film query was down. Actually, you could, if there was a cache of the ones last offered for the search, and cache that, you could just offer that out of the cache. So what, here's some examples literally from Netflix as well, of where they use caching in 3 different ways for availability. One is, what was the catalog presented? So it would normally do a search, again, knowing what you as an individual are, and it will give you a recommended for you catalog. Or think of YouTube the same, that they all do very, very similar. If it couldn't do that live query, it could actually have a cache of what was the last one it presented to you yesterday, or what if it was a general group of, if that wasn't even available. I know Michael Royster is someone from Manchester. I could go and offer here a set of films that people from Manchester have been watching as an alternative if I can't go to the normal search service. So there's an application caching. Netflix actually even goes so far as actually to mitigate DNS failures. They actually cache IP addresses for servers. I'm not sure this is the great practice, but it helps them mitigate out from an IP, a DNS failure, which obviously they must have had at some point. And
And another one, this was a simple change that they made. So if they can't ever get to like the account information, to be able to bill that in if they can't get to any of the account information, they can actually still allow you to watch a film and actually can still bill you for it, potentially. Is that they found they could actually put the customer identifier in every single URL, and that solved a lot of availability problems. Just putting that value in the URL, which is really a cache of a value that's previously looked up. Yeah, and if you anyone who's ever looked at caching, this is something from Pat Helland, who's was in Microsoft a long time ago, but this is actually all still very, very true. I've looked at different database types, data types, and classifying them that can be cached. So things like reference data can be cached. Anything that is thought of immutable. So he goes through and classifies a lot of those. So that makes an easy way for you just to use a cache without sort of thinking about it for certain data types. Caching your current bank account, credit balance, your current balance might not work so well, but lots of data will cache well and give you improved availability as well as the performance. The other approach is something Microsoft do to improve availability is to actually have what's called stamps. So rather than what we do is test. We know a certain application tier and a certain database size. We know how they scale. We've tested it many times. So if more load comes onto the system, what we do is just deploy another stamp in a well-known configuration and keep just repeating that and adding more stamps. This is how we do it. The alternative, which causes more problems, is let's go and add more application servers to scale out. That works for a while, but suddenly you will hit the point where it's then breaking the database. There's too many, or the load, or scale one up, and similarly you move into configurations that are not tested, which results in poor resilience and poor availability. By having well-known stamps and we know how these applications behave in that configuration, we just cut to those and bring a stamp on and put behind a load balancer, rather than trying to go and scale things up and down at the time. So that's another approach for apps improving the availability. And another one is throttling. So rather than allowing load just to build up, such that every single feature starts or every single user starts then getting impacted, an alternative approach is to actually start throttling, and as new requests that new users are coming on, throttling them back, or requests throttling them back so they don't add more load to the system and make it more reliable. Some requests are going to come back as failed, but at least keeps the whole system as available. I think I'm coming up to about a minute left. Is that right, Phil?
Yep, that's right, Michael.
So I'll probably leave, end with any questions rather than just going on to the end. So I'll pause there and leave some time for a question or two.
Looks like you've stunned everybody into silence.
I can ask you one, Michael, if you like.
Yeah. So, yours are always hard, Nick. You never ask easy questions.
No, it's quite general, actually. So I was looking at the geo-replication capability of Service Bus, and I was sort of considering the cost-benefit relationship between the standard and the premium.
So what was the service, Nick? I missed the key word. Sorry?
Service Bus.
Service Bus.
Yeah.
Yeah.
and I did like a calculation. It was actually pretty expensive. It had ASIM in there as well, which is a different question altogether. But so I started doing a POC with basically sending to 2 standard service buses.
Yeah.
And idempotently handling the messages, basically. And I, knowing your experience, is that something you've come across before? Given that if I use premium, I'm sort of going to have to do that anyway.
Yeah, I don't think premium for Service Bus adds any value from that geo perspective, because it has some geo-replication service capability, but it's really helping the failover. It's only the metadata that goes across and helps you with a failover in the namespace connection string. But for the content, you've got to solve that so that anyway, whether it's to replicate, there is some replication now on Service Bus to replicate to another instance, but you may as well have 2 instances which can be standard and do that because you write to it yourself. Service Bus, what does drive it to premium for me usually is the availability zone support, which they have put that in premium, which I'm never that keen on.
Made a bit harder for me, given that one of mine is UK West, which is sort of So basically, I'm not mad. Is the conclusion?
No, and I've seen. If you remember the central engineering team, I've seen them make that recommendation as well. That's not just my personal view. I've seen that from others as well.
Cool. That's brilliant. That's great. Thanks, Michael.
Yeah, it was brilliant. Thank you, Michael.